Hello everyone, I'm Xiansheng Math. Welcome to the next part of Ivy Global Math ACT practice test. We're starting this one on question 19. Please read through and try these problems before you watch the video. That will give you the most benefit from them. Okay, what is the sum of the two roots? 19 says, what is the sum of the two roots of the equation x squared minus 7x minus 60 equals 0? Okay, so we want to see what values of x will make this equal to 0. Remember, with quadratics, a lot of them can be easily factored. So we want to think about this being in factored form. Why is that important? Well, we know that if the product of two numbers is 0, one of them has to be 0. If a is 0, 0 times b is 0. If b is 0, a times 0 is 0. So when we have a product of two numbers, which is 0, one of those factors has to be 0. So we want this to be in factored form. So it's going to look something like this, and then we'll have this factor times this factor equal to 0. And we can use the zero product property to figure out what the roots are, and then we can find their sum. So whatever number goes here and here, well, these get multiplied to give us the negative 60. So these two numbers must have a product of negative 60, and these two numbers will add to give us this coefficient of negative 7, so they must have a sum of negative 7. Okay, systematic way of doing this, I could go, well, let's see, 1 times negative 60 is negative 60, negative 1 times 60, 2 times negative 30, negative 2 times 30. So let's see what these sums are. Well, this sum is negative 59, this is 59, the sum of these two is negative 28. And it looks like if I continue, 3 times negative 20, negative 3 times 20, and 4 times negative 15, negative 4 times 15, 5 times negative 12, negative 5 times 12, and 6 times negative 10, negative 6 times 10. Okay, 60 has a lot of factors, so we got a lot of these. And these aren't very close to 0, so let's try this. Negative 6 plus 10 is 4. So these numbers have a product of negative 60, a sum of 4. These have a sum of negative 4. And these are getting closer to the negative 7. So let's try this. We get a sum of 7. Here is sum of negative 7. And this is what we're looking for. Okay, so 5 and negative 12 have a product of negative 60 and a sum of negative 7. So that means we want x plus 5 and x minus 12. All right, so if we multiply this out, and we did the first, outer, inner, last, so we multiply first terms, x squared, outer, the opposite of 12x, the inner, 5x, and the last, negative 60. We add these up, we get x squared minus 7x minus 60. So we see that x plus 5 times x, the quantity x plus 5 times the quantity x minus 12 is equivalent to x squared minus 7x minus 60. So now we have two factors that have a product of 0. So one of them has to equal 0. So x plus 5 must be 0, or x minus 12 equals 0. Well, if x plus 5 equals 0, we subtract 5 from both sides and we get x equals negative 5. If x minus 12 equals 0, we add 12 to both sides. We get x equals 12. I guess I better show that. Okay, so our two roots are negative 5 and 12. And the question says, what is the sum of the two roots? Well, negative 5 plus 12. Okay, these are our two roots. Their sum is 7, and that is C among the answers. Okay, so the answer to 19 is C. All right, 20 says, Ella is making a princess costume, which includes a tiara, a gown, a pair of gloves, and a pair of shoes. If she chooses from 7 tiaras, 9 gowns, 4 pairs of gloves, and 3 pairs of shoes, how many possible different costumes could she make? Well, let's see. Sometimes people get stuck on this. So best approach, let's say you absolutely have no idea what to do on this, is to simplify it a little bit. Let's just pretend she has 2 tiaras and 3 gowns. Okay, so let's say she has a golden tiara and a silver tiara, and let's say she has a white, a black, and a green gown. Okay, how many different costumes could she make with that? Well, she has the tiara. Okay, so she could have a silver or a golden tiara, and then she has a white, black, and a green gown. So her gown, she could have a white gown with a silver tiara, a black gown with a silver tiara, or a green gown with a silver tiara. She could also have a white gown with a golden tiara. She could have a black gown with a golden tiara, or she could have a green gown with a golden tiara. And at this point, I realized she could have 6 different costumes, combining those. I look at the 2 and the 3, and that to me suggests multiplication. So if we extend it and we see, let's say she does have 4 pairs of gloves, and let's just call them 1, 2, 3, 4. Well, we see you would have 1, 2, 3, 4 here. 1, 2, 3, 4 here. And so she would have 4, 8, 12, 16, 20, 24 possible costumes. And that even more strongly suggests multiplication. 2 times 3 is 6, times 4 is 24. So now I apply that to here in order to find out how many costumes, and that is the case. How many costumes she needs? We need to multiply the number of tiaras by the number of gowns, by the number of gloves, by the number of shoes. So let's do that. Let's do the 7 times 9. Multiplication can be done in any order. So we can do 7 times 9, that's 63. 4 times 3 is 12. And we multiply 63 times 12, and we get 756. And that is choice K. So number 20 is K. All right, number 21 has to do with a little bit of trigonometry. So let's get some space here. All right, so 21 says the hypotenuse of the right triangle BLT shown below is 25 meters. the tangent of angle T is 4/3, how many meters long is BL? Okay, so we're told this, the hypotenuse across from the right angle, is 25 meters. And we're asked, what's the length of BL? And we're told the tangent of angle T is 4/3. Okay, so tangent is the ratio of the opposite side to the adjacent side. So the side opposite angle T is this. So I'm going to put an O there, opposite. The side adjacent is A. Okay, so let's make a triangle. It just shows the 4 and the 3. So here's angle T. The opposite is 4, the adjacent side is 3. So the tangent of T is 4/3. This triangle is similar to this triangle. That's the idea of the trigonometry. As long as the tangent, as long as one of the trig functions has a certain value, any other triangle with that well, okay, just strike that. So we're just going to continue from here. This triangle is similar to this triangle. All right, so, well, this is 3, this is 4, and we can see it's the right triangle, so we can use the Pythagorean Theorem. So we can use the fact that in the Pythagorean Theorem, the sum of the squares of the legs is equal to the square of the hypotenuse. These are the legs, since they form the right angle. So we have 3 squared plus 4 squared equals x squared. And 3 squared is 9 plus 4 squared is 16 equals x squared. And then we got 25 equals x squared. Take the square root of both sides. X is equal to 5. So in this triangle, this side, BT, if we're using a smaller scale version, is 5. And this triangle is similar to this triangle. So we can find a scale factor that goes from here to here, and that would be 5. 5 times 5 is 25. So 5 times 3, this side would be 15. 5 times 4, this side would be 20. And it's asking for the side of BL, and that's 20. So 21, the choice is E. All right, next one, 22. We'll stop after this. All right, 22 gives us coordinate plane and asks us, in the standard XY coordinate plane below, 3 of the 4 vertices of a square are shown. Which of the following coordinates is the 4th vertex of the square? Okay, so we have these 3 vertices, and if you look at it, it looks like the 4th vertex should be somewhere over here, and that's in the 2nd quadrant. And in the 2nd quadrant, we know that the x-coordinate is negative and the y-coordinate is positive. So let's see if we can eliminate choices that way. No, we can't, because they all have a negative x-coordinate and a positive y-coordinate. Okay, what's important here to make sure you have the right answer is, what is a square? Well, what makes a square a square? Well, it has all sides are congruent and all angles have a measure of 90 degrees. Okay, and what is that? What's another way of looking at that? Well, if this side and this side form a right angle, 90-degree angle, then their slopes are then the sides are perpendicular, and if two lines or line segments are perpendicular, they have opposite reciprocal slopes. So opposite reciprocal slopes. So opposites when they have different signs. Reciprocal is two numbers whose product is 1. So let's see. 2 2 times 1/2 is 1, but they also have to be opposite. So one of these would have to be negative. So negative 2 times 1/2 is negative 1, or 2 times negative 1/2 is negative 1. These numbers are opposite reciprocals. Another way of talking about opposite reciprocal slopes is if the product is negative 1. Okay, another example would be, say we have 3/4, well, the reciprocals 4/3, and opposite reciprocal slopes, one of them has to be negative, or one of them has to be the opposite sign. And then we see that negative 3 times 4 is negative 12. This is 12, so we'd have negative 12 over 12, which is negative 1. So we're looking for slopes like this. That will tell us that the sides are perpendicular, or that the angle measures are 90, and then we need to find the distance between the points. So there are quicker ways to do this, but I'm going to go through and talk about the specifics so that we know that we have a square. So if all the sides have the same distance, then we have the square, and if all the angles are 90 degrees, that is, each pair of meeting sides have opposite reciprocal slopes, then we know that it's that all the angles are 90 degrees. So let's see. What is the slope between these two? So here we find the change in y, the change in x. So we can go 4 minus 2, and then negative 1 minus 1, and we get 2 over negative 2, and that's equal to negative 1. All right, so the slope between these 2 points is negative 1. What's the opposite reciprocal of negative 1? Well, what times negative 1 equals negative 1? 1. So this is going to have a slope of 1 for these to make a right angle. And so let's find the slope. And we know that's the case, really, because we're told that these are 3 vertices of a square. So let's see, we find the change in y here, and that's 2 minus 0, and then 1 minus negative 1, so we get 2 over 2, and we see these two slopes are opposite reciprocals, so yeah, this side and this side form a right angle. So we want to point over here so that this side and this side have opposite reciprocal slopes. They now need to be 1 and negative 1 because these sides have to be parallel and these sides have to be parallel, so these slopes have to be the same. This has to be a slope of negative 1, and this has to be a slope of 1, just like this side. So we can use that to narrow down our choices. So let's say we pick the first one, okay, negative 3, 2. So let's say we think this vertex, which looks like it'll be right around here, is negative 3, 2. Okay, so that means the slope between this point and this point must be 1, and the slope between this point and this point must be negative 1. And this is choice F. All right, so let's find the slope between these 2 points. So we'll have 4 minus 2 over negative 1 minus negative 3. And we get 2 over, that's 2. So this has a slope of 1, and this has a slope of 1. So that's looking good. We also want to see that the slope between this point and this point is negative 1. It must be parallel to this. So let's do that. So we have 2 minus 0 over negative 3 minus negative 1. And we get 2, and this is negative 2. All right, so here the slopes are good. Okay, so we know that if this point is negative 3, 2, then all of these are right angles. Okay, that's part of it. So this part we've shown. We still need to show that the sides are congruent. So there we need to consider the distance formula. And I'm not saying all of this work needs to be done. I'm just trying to make sure that you do have to do whichever steps you have those tools in front of you. Okay, so let's see what this distance is. Remember, the distance is the square root of the difference of the y values and that quantity squared plus the difference of the x values and that quantity squared. Okay, so let's see. What is this distance? Once we find this distance, we know this distance and this distance must be the same because all the sides have to have the same length. Okay, so here we would have, let's see, 4 minus 2 quantity squared plus, let's see, negative 1 minus 1 quantity squared. And this is 2 quantity squared, so we have 2 squared plus negative 2 quantity squared. So we have 2 times 2, which is 4, plus negative 2 times negative 2, which is 4. So the square root of 4 plus 4, which is the square root of 8. And we don't need to do any other work because if we see the other things coming up with the same value, we know those sides are congruent, they have the same measure. So let's see if the distance from negative 1 4 to negative 3 2 is also the square root of 8. And then we need to check that the distance from negative 3 2 to negative 1 0 is also the square root of 8. So is this distance the square root of 8 and is this distance the square root of 8? Again, if you can do that in your head, that's fine. I'm going to go ahead and show the work. Okay, so now we're checking this side. Again, we're using negative 3, 2, and this is what you do with each of those choices. Remember, you're verifying. Are the sides perpendicular? Do they have opposite reciprocal slopes? And do the sides all have the same measure? Is the distance from one vertex to the next vertex always the same value? All right, so we're checking negative 1 4 and negative 3 2. So we want to find the difference of the y values. So 4 minus 2. And then we square that. We want to find the difference of the x values. Negative 1 minus negative 3. And square that. So here 4 minus 2 is 2. So we got 2 squared plus, let's see, that is also 2. And this is going to be 4 plus 4, square root of 8. So this side has the same measure as this side. They both measure square root of 8. Once we know this distance is the square root of 8, then we'll know all the sides are congruent. This was given to us, so we don't need to find it. So let's find the distance from negative 3, 2, which is what we think this probably should be based on our slopes, and negative 1, 0. So again, we're going to find the difference of the y values in square. So we have negative 3 minus negative 1. And then we add that to the difference of the x values. So we have 2 minus 0. We'll square that quantity. And then here we get negative 3 minus negative 1 is negative 2. And 2 minus 0 is 2. We'll square that. So we get negative 2 times negative 2, and that's 4. 2 times 2 is 4. So we have the square root of 4 plus 4, which is square root of 8. So these sides all have a measure of square root of 8, so all the sides are congruent. We've checked the angles. So this is the missing vertex, and that is choice F. So for 22, the answer is F. Okay, again, please try these problems before you watch the videos, and just select the ones that you need help with. Thank you for watching. Please like, subscribe, comment, and share. And thank you again. Xiansheng.